Hey guys, so in this week's tutorial we looked at first sets, follow sets, select sets, and LL1 grammars. And in today's tut, Lee, one of my students, pointed out that I'd been applying the follow set in the three tutorials wrong. So I decided to make a video to provide clarification on how to follow how to compute the follow set algorithm, and we'll be producing the correct output for the 5 follow sets, the select sets for S derives A, B, B, C, D, and S derives the empty string, and then we will be using those two select sets to prove that our grammar is not LL1. So let's get started. And to begin, what we're going to do is for the follow set of S, we need to find all the S tokens on the right hand side of productions. So there's one here, and one here. And then what we're going to do is we're going to circle everything to the right of the S. So there's one here, there's one here, and there's one here. And everything in the red circles are going to be, we're going to compute the first sets for those. So the first set for D, the first set for AC, and the first set for F. And then we're going to remove the set containing the empty string. And the first set for D is just going to be the set containing D. The first set for AC is going to be, so if we head over to A derives the empty string, so the empty string is one particular one, but because of this, because we're removing the empty string, we're not going to include that one in our set. And then because it derives A, we can just ignore that. We then go to the production S, and that gives us an A. But because S is nullable, which means that it derives the empty string, we also need to include D from A. And because A is nullable, we also need to include C from AC. And we will also include the set containing F, which gives us A, C, D, F. And there's one more thing that we need to do. Because S is the start symbol, we also need to union this with the end of file token. And that will give us the follow set for S. So now let's compute the follow set for A. And so here what we do is we look for A on the right hand side, and then we circle everything to the right of the A. And that will give us, and now what we want to do is we're going to compute the first set for everything that's been circled in red. So that will be first of capital B, lowercase b, C, D. And the first set for S, D. And the first set for C. And then we're going to remove any empty strings. And because A is not a start symbol, we don't need to worry about including the end of file token. So let's now take a look at the first set for BBCD. That will be, so if we head over to B, well, we can get the first set for for S, which is A, or epsilon, which is the empty string, but because the empty string is being removed, we won't include that one. We can also get the first set for A, and A derives as A, S. We've already included everything in S, so then we can get D. And because A is nullable, we can also get C. And then we can also add E. And because B is nullable as well, we need to include the lowercase b, and that will conclude the first set for capital B, lowercase b, C, D. And now we will take a look at the first set for SD. For SD, it's simply going to be A, D. And we will take the union of the first set for lowercase c, which is just C. And then because we are taking the union of these three sets, it will simply be A, B, C, D, E. And now I'm just going to move this up, because I think B is the biggest one. And now we're going to compute the follow set for B. So the first thing we do is we circle any B's on the right hand side, or box them, and then take our red marker and we circle all the following characters. And now we compute the first set for lowercase b, capital C, capital D, along with the first set for D. But D, and then we'll remove the empty string set. Now D is also nullable, which means that we need to include the follow set for D in B. So we'll come back to this one in a moment. And we'll compute the follow set for C now. So the first thing we do is we look for all the C's on the left hand side, sorry, on the right hand side. And there's one here, and one here. And then we'll circle everything that comes after. Now, we'll compute the first set for D, along with the first set for G, and the follow set for B, because we aren't able to get anything else that derives to the empty string in 0 steps, so we are just going to be computing the follow set of B. And I'm omitting the follow set for D because the follow set for D is implicitly contained in the follow set for B. So now what we'll do is we'll compute the follow set for D, and the follow set for D is going to be all the D's on the right hand side. Because they're the only D's, and they're both derivable to the empty string in 0 steps, our D is actually going to be just the follow set for S, which means that we can now solve both B and C. So the first set for lowercase b, capital C, capital D is just going to be the set containing C, and the first set for D is going to be A and the empty string, but we're removing the empty string so we don't include it. And we're going to include the follow set for D, which is the follow set for S. That's A, C, D, F, end of file. And so that will be A, C, D, F, and I think I'm missing something. A, B. Yes, I'm missing B. Silly me. That was meant to be a B there, sorry. A, B, C, D, F, end of file token. And finally, we can compute the follow set for C, and that's going to be the first set for D, which is less the empty string, which is just going to be A, along with the first set for G, which is just G, along with the follow set for B, which is A, B, C, D, F, end of file. And then when we take the union of those, it's A, B, C, D, F, G, end of file. And now we have produced all of the follow sets for our grammar. And finally, what we're going to do is we're going to take the follow sets along with the first sets, and we're going to produce the select sets for the production S. The first such production is select S derives lowercase a, capital B, lowercase b, C, D. And this produces, well, what we need to do is we need to, if we have an empty string in the set, then we consider one case. If there isn't an empty string, we just take the first set of the right hand side, which is going to be A, and the select set for S derives the empty string is going to be the empty string minus the empty string, because it's the first set of the empty string minus the empty string, along with the follow set of S, which we have worked out to be A, C, D, F, end of file. And now that we've worked out this, we can show that our grammar is not LL1, because the intersection of the select set for S deriving A, B, B, C, D, and the select set for S derives epsilon will be the set including A, which is not equal to the null set, which means that there are two derivations for the same production where we can get the same terminal, and that produces an ambiguous grammar. So to recap, we computed the follow sets in this video, then we computed two select sets, and we used these select sets to prove that our grammar is not LL1 because it is ambiguous. If you have any questions, please feel free to post them in the forum, but don't leave them as YouTube comments because other students may not see them there. Thank you for going through this again, and I'll see you next week.